today we are going to discuss red black tree deletion. Okay, in the last video we discussed the insertion in red black tree. Now this is in continuation with that topic only, how to delete a node from a red black tree. So as we know that red black tree follows the property of binary search tree along with some of its own property associated with red or black color. So deletion is also associated with that only. So for performing deletion operation on red black tree, it must be performed in such a way that all the properties of binary search tree along with the red black tree are not disturbed. It will retain all the properties of RB tree as well as BST. So for that, there are some cases. So what case one says, if either of the node to be deleted or the node parent is red, then just delete it. Means if we are deleting a particular node which is the leaf node that is red in color, we can just simply delete it. It will not impact anything on the red black tree because it is a leaf node, and what matters in red black tree is the black height. So whenever we are going to delete a red node, it will not impact anything on the RB tree. Now case 2, if the node is a double black, in that particular case, just remove the double black. Now what is double black? Double black occurs when the node to be deleted is black and leaf as it adds up a null node which are considered black colored nodes. Means whenever we are going to delete a black node, what it will do? It will add a black color to its parent node. It will become a double black node because leaf node has nil nodes which are black in color. Now if the double black sibling node is also black node and its child node are also black in color, then follow the simple steps. That is, remove double black, recolor its parent to black, recolor the parent sibling with red. If double black node still exists, we apply other cases. Now case 4. If the double black node sibling is red, we perform the following case. That is, swap the colors of parent and the parent sibling node. Parent node and parent sibling node, not child. Rotate parent node in the double black's direction and reapply other cases. Now case 5. If the double black sibling is a black node, but the sibling child node that is closest to the double black is red, then swap the colors of double black sibling and the sibling's child. After that, rotate the sibling node in the opposite direction of double black and apply case 6. Means whenever we apply case 5, we have to apply case 6 also. And what is case 6? If the double black sibling is a black node, but the sibling child node that is far to the double black is red, in that particular case, swap the colors of double black's parent and sibling nodes. Rotate the parent and double black's direction. Remove double black and change the color of red child node to black. So these are the various cases associated with the deletion in a red black tree. So now consider this particular tree. We are going to apply deletion cases on this particular red black tree. First of all, check it is a red black tree or not. It is a perfect red black tree as it is following all the properties associated with the BST as well as RB tree, that is red black color. Now question says, first of all delete 4. Now 4. See, 4 is this. We have to delete 4. The color of the node 4 is red. Plus 4 is a node which is having 2 child. So the deletion process will remain same as we did in BST along with the RB property, red black tree property. So whenever we are going to delete a node which is having child in BST, the process says delete the node or replace the node with its in-order successor. So the in-order successor of 4 is 5. So 5 will replace this 4. After that, we will delete this 5 because this is the duplicate data. So what we will do? The in-order successor. First of all, we will calculate the in-order successor of 4. That is 5. Now replace 4 with 5. So replace this 4 with 5. And now delete this 5. So whenever we are going to delete this 5 is red in color. So as the case 1 says, we can simply delete it. So we deleted the node 5. There is no other impact on the tree. So how to delete this 5? So again see, 5 is red in color and it is also having 2 child. So what BST deletion says? We have to replace this 5 with its in-order successor. So its in-order successor is 6. The in-order successor of 5 is 6. So we are going to replace this 5 with 6. First case. Okay? Next, when this 6 will replace this 5, now we have to delete this 6. Now this 6 is having only one child, that is 7. So in that particular case, what it will do? 7 will replace this 6. So 7 will come at its place. And finally delete 7. So your tree will look like this. But RB tree property is violated after the binary deletion. Now check, all the paths are not having same black height. You can check. Here we have 1, here we have 2, here we have 1. So property is disturbed. So what we have to do? We will swap the colors to balance the tree. So parent and child color will be swapped like this. Now check the black height. 1, 1, 1. Tree is balanced. Next, we have to delete 3. Now, the case arises of double black. 3 is black in color. It is a leaf node, but it is black in color. If I'll delete this 3, property of the tree will get violated. Black height will get disturbed. So, it is being replaced with a double black node. This is double black. It will get the color of its nil node, because in BST deletion is not simply deletion, it is being replaced by its in-order successor. So in-order successor is a nil node and it is having black color. So here we will get a double black node. Now we are having a double black node. So it means some of the cases will be applied here. So here we will apply case 3. What is case 3? If double black sibling node is also black node and its child node are also black in color, then remove double black, recolor its parent to black, recolor parent sibling to red. Okay. So, we are here. Now check its sibling. Sibling is black. And siblings child are also black because 7 is the leaf node. So, it is having nil child and nil are black in color. So, what is going to be done here? Remove the double black. So, we will remove this double black node. We will remove it. And change the color of parent to black. That is, recolor the parent color and recolor the sibling color. So, sibling color will become red and parent color will become black, like this. Now check if still a double black is there. No, there is no double black. So, we will stop the process. And also check every property of RB tree is fulfilled. Check the black height of the tree. It is perfect. One here, one here. So, after deletion of 3, we will get this final tree. Now comes the search operation. How searching is done on the red-black tree. So, searching operation is being performed in the similar way as we perform in the binary search tree. Okay. For example, if I want to search 6, so in BST, what we will apply? We will compare with the root node. 6 is greater than 2. We will go to the right subtree. Now node is 6. 6 is equal to 6. Search is successful. If I want to search -4, in that particular case, 2 is compared with -4. -4 is less than 2. So we will go to the left subtree. Next we have 1. -4 is less than 1. We will go to the left. But there is no tree existing. So search is unsuccessful. So the similar way will be there for searching the elements in RB tree as we were following in the BST. Because for searching we do not require any kind of coloring and all. That is simple. We have to compare the data. We have to compare the node data along with this required data, and if it matches, then search is successful. If it is not matching, either we will traverse to the left subtree or to the right subtree. And the process goes on until and unless search is successful or unsuccessful. Is the time complexity. Now, as each node in RB tree contains an extra bit that represent color to ensure that the tree is balanced during any of the operations performed. O1 is the best case and ON is the worst case. In binary search tree, the searching, insertion and deletion takes O of log n time in the average case. Similar is with the RB tree. Next, what are the various applications of red-black tree? Red-black trees are used for implementing finite maps or to implement Java packages or to implement standard template libraries in C++ or in Linux kernel. So, it has a wide range of applications which is being used in the computer science. And some of them are implementing maps and sets, priority queues, file systems, memory database, graphics and game development. So, we can say that RB trees have a huge application area or domain where we can use the concept of RB tree, as this is also providing a self-balancing representation of data. So, memory utilization is also perfect. Thank you so much. We will discuss more topics in the next lectures. These are the references.